Hello, my name is Damian Horton and I am a second-year chemical engineering student at Georgia Institute of Technology. I attended the final physics lecture of the semester on December 4th, 2015 at 7 o'clock p.m., where a professor from Harvard discussed the fascinating subject of the physical principles and properties present in our breakfast foods. The three breakfast foods discussed during the lecture were coffee, scrambled eggs, and cereal. As we all know, physics is all around us. It exists in everything we do and is a part of everything we are. This includes the foods we consume on a daily basis. The topic of this lecture interested me as soon as I heard it and thus influenced my decision to attend the lecture. In summary, the three main points that were discussed and that I learned a great deal about during the lecture were as follows: the coffee ring effect, the elasticity of scrambled eggs, and the Cheerios effect. I plan on discussing with you the topic I found most interesting and memorable, the coffee ring effect. It is my hope that you will learn something from this presentation that you did not originally know before clicking on the video's play button. Let's get right to it, shall we? I'm sure we've all seen how drops and splashes of spilled coffee leave a ring behind after the majority of the coffee has evaporated away. To understand this, it is important to understand what coffee is. It is not a simple and pure solution such as water. It is an emulsion and a suspension, meaning it has various particles floating around throughout it. These particles exhibit both cohesive and adhesive forces, which are properties of something called surface tension. When a drop of solution falls onto a surface, the adhesive and cohesive forces between the molecules, both macro and micro, combine. The attractive forces between the molecules force them to collect at the center of the drop, which is why a spherical cap forms. The molecules and particles within the solution also exhibit repulsive forces, which causes them to be pushed outward toward the edge of the drop. Because of surface tension, the edges of the drop are effectively pinned down to the surface that they are attached to. As the coffee dries, the particles at the edge evaporate away at a much slower pace than the particles toward the center due to lack of movement. The center or interior particles move toward the edge of the drop to replenish the molecules at the edge that have evaporated away, as can be seen in the picture. This is why the coffee ring effect occurs. Pretty cool, huh? So, how is this all useful and why does it matter? As it turns out, the coffee ring effect is an important phenomenon that is being studied and used in the diagnosis of medical diseases. Doctors are taking samples from patients and are seeing if, once incorporated into some medical procedure, these samples leave behind coffee rings. The rings left behind may be indicators of disease. This idea inspired me to think about the time I witnessed the coffee ring effect in action myself during an actual medical procedure. This would normally be considered something private, but I don't mind disclosing it to you if it helps provide a realistic example. During one of Georgia Tech's campus-wide HIV testing events, I decided to get myself tested. As the examiner took my blood, dissolved it in some solution, and placed the mixture in a tiny basin in front of me, he asked me to look closely. If one ring formed at the bottom of the basin, I was HIV negative. If two formed, then I was HIV positive. Only one ring showed up as I expected it would. I never really thought back on that test until I attended the lecture, which made me consider the possibility that what I witnessed during the test was the coffee ring effect in action during a credible medical procedure. If you haven't fallen asleep yet, it is my hope that you have learned something that you did not know before clicking on this video, and that I have encouraged you to do your own research on the topic to further your own understanding. Thanks again for watching and have a pleasant evening. Hope you enjoyed.